I wanted to do a follow-up for the vectors simulation and show you some of the things about what's going on here with this value, absolute value of r, and the angle, and the rx and the ry. Also talk about components a little bit. So first of all, let's just pull a vector down and play around with it, moving it around a little bit. You can see that the r value here is always changing. Well, first let's talk about this. It's clearly going to be the angles. Let's stick this down here, right there at the origin. And if I change the angle around, then the angle changes as well. So that makes a lot of sense. If I stretch it out and squish it back, then you're seeing this r value change right here. This r value is going to stand for the total length of this vector. So from there to there is the r value, just like that. The rx and the ry are telling you how much of this vector is going in the x direction and how much of this vector is going in the y direction. So when I change these around, you can see if I bring it all the way down to the x-axis, then my rx value and my ry value goes to 0. My rx value is going to be the same as my absolute r value right here. If I drag this all the way up to the y-axis, just like that, then you see that my r absolute value number is the same as my ry value. And then in between, if I get my rx and my ry to be the same, let's see here. Okay, good. Maybe 20 is a better number, 20 and 20. Then rx and ry, if I take 20 squared plus 20 squared and take the square root, then I'm going to get what this value is right there. So that's what's going to happen. Now, components are a way to actually visualize what's happening there. So if I click on components right here, what the pink arrows are showing is the pink arrow is showing how much of this red arrow is going in the x direction and how much of the red arrow is going in the y direction. So how much of this red arrow is in the x direction? The length of this red arrow, the pink arrow, is actually now 20 because that was how much of my red arrow was in the x direction, and the length of this pink arrow is 20 in the y direction. As I change those around, you see that they change around as well. So the components are what would happen if I took this red arrow and I broke it into pieces. And I said how much of that is going in the x direction, how much is going in the y direction. Sometimes it's nice to have them like this and to bring one of them over here. And now just to make up an example here, let's say you were trying to get from your house, which is down here, and you're trying to get to the grocery store, which is over here. One way you could do that is just by starting here and walking in this kind of northeast direction for 33.6 miles or meters or inches or whatever it is, and you'd be right here. Another way you can get there is if you started here and you walked along the x-axis and you walked for 27, let's say, meters along the x-axis, and then you turned and went in the y direction for an additional 20 meters, and you went from there to there, then you'd get to the same spot. And with vectors, you're always welcome to take one vector that's going at an angle and change it into one vector that's going on the x direction and one vector that's going in the y direction. If I click on style 3 over here, then that just brings up this nice box over here so you can see that this is makes a rectangle. Good. We can do the same thing with the sum of the vectors. Let's click the component display off. And the sum of the vectors, if I go here and I go here, one thing I wanted to show you is that you can add vectors by components. So let's say I have these two vectors right here. One of them has a length of 13, and then this one has a length of 18. Let's say I wanted to add these together. Well, actually, let's start in a simple situation. Let's take this one, and we'll bring it this way, and it has a length of, I don't know, maybe 10. Oops, and we'll make it entirely perpendicular. Hey, stop that. 10, and then we'll take this one, and we'll make this one have a length of, say, also 10, and it was in this direction. If I want to figure out the result of when I add those together, so how do I figure out what the length of my result is? Well, it's easy when they're perpendicular to each other. I can just stick them like this. You can see that the result is going to come here, and then I'm just going to do Pythagorean theorem. So I have the length of this one, which is 10, and the length of this one, which is also 10. 10 squared plus 10 squared square root gives you 14. Right? So that's 10 root 2. But things are a little trickier. Let me click this off. Things are a little trickier if I'm going off at a funny angle. If I have that one at a funny angle, and let's say I have, where are we here? This one kind of also going off at a funny angle. Now I've got this one as the length of 10.8, and this one has a length of 19.8. If I try to add them together, I can't really do a Pythagorean theorem here. Let's make it even more, because I don't really have a right triangle to make a Pythagorean theorem. Let's make it more off. So I don't have a Pythagorean theorem. I can't do it. So how do I find the length of this green one? Okay, I just clicked on it, so we know that that length is 19.4. How can I actually figure that out? Well, it's a little bit tricky, but I can actually use components to help me out. So if I display these components here, and, oh, let's see, is it doing all the components? It's doing all the components. Yeah, so this is a nice way to do it. So for this vector right here, you can see that I have this much in the x direction plus this much in the y direction. For the other red vector, I have this much in the x direction and this much in the y direction. And that's actually displayed at the top here. So for this vector, I've got 14x and minus 5y. For this vector, I've got 14x and 14y. So how can we do that? How can we add them together? If I click on this vector, let's look in just the x directions right now. So I've got 14 in the x direction for this vector. And I click on this one, and I've also got 14 just randomly in that one. So I should be able to add the x component of one plus the x component of the other. And if I click on the green, look, 28. That was my 14 plus 14. Let's look at the y components. Click on this vector, and the y component here is minus 5. Click on this vector, and the y component is 14. So I have minus 5 plus 14. If I click on the green one, then that gets me 9. So I can quickly find out the components, the x and y components of my sum vector. I don't know what this, oh, I see. This green arrow right here is the sum component. So there's another green arrow buried back there. But I can find the components of my sum, the 28 and the 9, by just looking at the individual x component, 14, x component over here, 14, that makes 28. And then y component of this one, minus 5, y component of this one, 14. And then I can figure out my x and y components overall of my resultant vector. And that works, pull this one over here. Any way that I want to move these vectors around, I can always add the x's and the y's independently of each other, right? So there you go. That's that. And I think that's all I wanted you to know about the vector addition.